Okay, so in this video, what I'm going to show you guys is how does the Cramer's rule apply to a matrix which is a 3 by 3 matrix. Okay, um, so essentially, what we're actually now talking about is we're talking about a system of equations which has actually there's three equations and three unknowns. So we're looking at this system, okay, which is a11x1 plus a12x2 plus a13x3. Let's say this is equal to b1 a21x1 plus a22x2 plus a23x3. This is equal to b2. So now you have an equation with, and then a31x1 plus a32x2 plus a33x3 equals to b3. So for here, what you can do is you can just take all the coefficients a11, a12, a13, a21, a22, a23, a31, a32, a33. This into now, since it's three variables, x1, x2, x3, this is going to equal to b1, b2, b3. Okay, so essentially, if you have a system of equations with three equations and three unknowns, x1, x2, x3, you can write them in a matrix form. So now the matrix A is a 3 by 3 matrix because there's three unknowns and there's three solutions to the system. Now how do you use the Cramer's rule? So the Cramer's rule is the solution of x1, it's again going to be equal to, so you're going to do again 1. So you're going to take 1 divided by the determinant of this matrix. But now remember that when we're doing but the 2 by 2, what were we doing? So so we were actually replacing for x1 we were replacing the first column with the solutions here, right? So you're going to do the same, but now it's a 3 by 3 matrix. So now it's going to be this into from this matrix you're going to eliminate this column and replace it with this. So it's going to be b1, b2, b3, and then all the other elements here, a12, a13, a22, a23, a32, a33. Okay, so this is actually what the Cramer rule says. The Cramer's rule says this is what x1 is going to equal to. It's going to be 1 divided by the determinant of A into this matrix where the first column is being replaced by the first row. Is being replaced by the solutions here. But then how do you find the determinant of this? So this is a 3 into 3 matrix, right? So how do you find the determinant? Well, it's now we have to remember the 3 by 3 matrix determinant. So it's going to be b1, but when you take b1 you eliminate this and then you do into these numbers here. So this is just x1, so you can see it's fairly lengthy, right? So what's going to be x2? So let me see, what does the Cramer rule says it's going to be x2. The first element is always 1 divided by the determinant of A. But now to find x2, what you're going to do is you're going to go back to this matrix here, but then you're now going to replace the second column with b1, b2, and b3. So your x2 is going to be 1 divided by the determinant of A into a11, a21, let's say a31. So my first, this column stays the same, but now this column is going to be replaced by b1, b2, b3, okay? So b1, b2, b3, and then the third column is going to stay the same. So the third column was a13, a23, a33, okay? So if you do this computation, you're actually going to find the solution of x2 as per Cramer's rule. And then finally x3 is again going to be 1 by the determinant of A. Sorry, this shouldn't be a matrix, this should be the determinant, okay? This should be a straight line, sorry, because you're going to calculate the determinant of this 3 by 3 matrix. So again, this should be a straight line. And then what should you write here? Again, let's just go back. So now from this matrix A, you're actually going to replace this third column by B1, B2, B3. Okay, so it's going to be A11, A2, A12, but now you're replacing the third column. So B1, A21, A22, B2, A31, A32, B3. Okay, so if you do this fairly lengthy computations, you can actually use the Cramer's rule and you get solutions for x2, x3, and x1 showed you in the previous page. So this is essentially just showing you how to use the Cramer's rule to solve for a system of equations where there's 3 equations and 3 unknowns. And you can try an example from the book. Let me show you the example that's in the book. Okay, so there's a system of equations which are given to you, and I won't work through, so I'll just do a part of it. So this is example 16.2.5. So this is example 16.2.5 from page 630. Okay, you're given 3 equations. So the 3 equations are 2x1 plus 2x2 minus x3 equals to minus 3. This is your equation 1. Then you have an equation 4x1 plus 2x3 equals to 8. And then you have an equation which is 6x2 minus 3x3 equals to minus 12. Now I'm not going to do the whole math for you, but let me just show you how to use the Cramer's rule to solve these 3 systems of equations. Now the first thing is I want to write these equations in a matrix form. But remember, if you want to write these equations in a matrix form, you have to make sure that all these coefficients are aligned. So it means that, so for example, the second equation, notice that it doesn't have an x2, right? But what does that mean? It does have an x2, so you have to imagine there's an x2 here, but the coefficient of that x2 is a 0. So what I'm saying is, first when you approach solving these systems of equation, if you want to write it in a matrix form, you should write it like this. So 2x1 plus 2x2 minus x3 equals to minus 3. But the second equation, you should write it like this. 4x1 plus 0x2. Okay? Because when you're arranging the coefficients in a matrix form, remember they have to be in order. So it's 0x2 plus 2x3 equals to 8. And notice the third equation doesn't have an x1, but you need to put a 0x1 plus 6x2 minus 3x3 equals to minus 12. Now you're ready to set this out in a matrix form. So first take all the coefficients, 2, 2 minus 1, 4, 0. So the 0 is important. 2, 0, 6 minus 3 into x1, x2, x3. This should equal minus 3, 8, minus 12. Okay, so now you have written these 3 systems of equation in matrix form. So this is your matrix A, this is your matrix X, this is your matrix B. Okay, now what will be the solution of x1 as per Cramer's rule? So the solution for x1 would be 1 divided by the determinant of matrix A into the determinant, where you now take this matrix, but remember, since you're finding x1, you replace your first column with the results here, So it's going to be minus 3, 8, minus 12, and then the next 2 columns will stay the same. 2, minus 1, 0, 2, 6, minus 3. Okay, so the Cramer rule says you can find a solution for x1 by finding 1 divided by the determinant of A, which is the matrix here, into this special matrix where you took the matrix A. But because we're solving for x1, we're replacing the first column with the results here, right? And then what would be x2? So for x2, I don't know if I can squeeze in x2 here. Let's see. So it's going to be 1 again divided by the determinant of A, into the determinant where now you're replacing the second column because it's x2 with the results here. So it's going to be the first column stays the same, 2, 4, 0, but then the second column gets replaced by minus 3, 8, minus 12, right? And then the third column stays 1, minus 1, 2, minus 3. And for finally for x3, you're going to replace, but I won't write it here, you're just going to replace this column with the results here. So this is how you use the Cramer's rule to solve for a system of equations which has 3 equations and 3 unknown. So it's obviously, it's very messy, right? Because you're having to find the determinant of this 3 into 3 matrix. But remember, the determinant of a 3 into 3 matrix is, remember, that has a lot of calculations in itself, right? Because remember, it was this, when you take this, then you find this into the determinant of this sort of the semi-matrix here. So yeah, it takes a lot of time when you're using the Cramer's rule, especially for a 3 by 3 for an equation with for a system of equation with 3 equations. But I guess the only slight bit of good news here is you just need to calculate the determinant of a once, right? Because notice that x1, x2, and x3 will all have 1 divided by the determinant of a. So, you've calculated the determinant of a just once, but these things you have to calculate 3 times, which takes a bit of time, okay? So this is how you use the Cramer's rule to solve for for an equation with for a system of equation which has 3 equations and 3 unknowns.